there. Sorry for the late start. Thank you for your patience. My name's Xavier. I currently work at Square on the production engineering team. And my details are up here. You can see them. And today I'm going to be talking about profiling Ruby. It's a thing that I've done a little bit of. I've sped up a lot of things. In some ways, this is kind of a weird talk for me to give because I'm actually not really that much of an expert at this. And I don't really even like it very much. But I really, really hate slow things. And that's been sufficient motivation to overcome the first two difficulties. And I've actually been able to speed up some slow things. And so I wanted to talk through that with you guys. To put it in Matt's terms from this morning, sometimes you just have to take out the garbage, right? So that's what this is for me. Now, this isn't a tools talk. I want to preface that. If you've come to learn the latest and greatest about sampling profiles, this is not that talk. I do cover some basic tools that you need to know about, but this is really about the mindset of how I go into this problem and how I approach it, and it's worked well for me. So there are three things that I'm always doing whenever I'm trying to figure out why something is slow. I'm hypothesizing, why could this be slow? What is this thing doing? Computers are really fast, and if I'm sitting there for 3 seconds waiting for a computer to do something, I have heaps of time to think about, well, what's it doing? It's got 3 seconds. That's a lot of computer time, right? So coming up with ideas, figuring out how to isolate those in order to test whether that's actually your problem or not, and then also figuring out how to instrument different things to figure out which bits are fast, which bits are slow, and then to prove that you actually sped a thing up. So I'm going to keep coming back to these 3 points. I'm going to work through a couple of examples of how I've applied this, and there's pretty graphs and everything. It's going to be great. To begin with, though, I wanted to talk more about the mental game of this, because I've certainly, for me, profiling has always been that kind of thing. It's like, it just seems too hard, right? And some of the best advice I got in relation to this was actually not computer-related at all. This was probably third year university. I moved into an apartment with one of my friends, and sort of fairly early on in the relationship, he was like, hey, do you want to play a game of Scrabble? I was like, oh, that sounds great. Do you guys know Scrabble, the board game? Hopefully everyone knows Scrabble. And I said, oh, great, love Scrabble. That's a fun game. I played that as a kid. So, we got a couple of beers, got the Scrabble board out, played this game. He absolutely smashed me. Like, he got a gazillion points. I couldn't put any words on the board. And afterwards, he was like, oh, wow, I really need to teach you how to play Scrabble. And that was kind of harsh, because I was like, it's just Scrabble. It's just making words. It's like, no, there's like, turned out his mum was like a pro Scrabble player, and all they did together was play Scrabble. And he really shocked me. But one of the best bits of advice he gave me, so we're playing along, and there's this thing in Scrabble called a bingo, where if you put all your 7 tiles, you get rid of your rack, you get a bonus 50 points. It's kind of a big deal. It's also kind of exciting, like laying down all 7 tiles. It's kind of, just feels really good, But like making a 7-letter word in Scrabble is really hard. I'd never done it before in my entire life. And like within the first couple of games, he's laid down a few of them. And I called him on it. I'm like, that's rubbish. Like, how did you manage to get all these 7-letter words? He's like, oh, you just need to look for them. I thought, well, that's useless advice, isn't it? But sure enough, I thought, okay, well, I'll try it out. In the next game, like every single rack I got, I'd just look at it and say, okay, can I make a 7-letter word? Like, no. And I kept trying, and then it was yes, I saw one, and like the very next game, I got my first 7-letter word ever. And I was so excited, and it all just came from, he's like, oh, you just need to look for it. And this has applied so much to me for speeding up code. It's really easy to sort of in your head say, oh, it's a popular library, like much smarter people than me have looked at this. Surely, maybe there's some micro-optimizations, but I don't know how to find those. You really need to actually, that's a really negative mindset. You need to come in believing that you're going to find something. You need to sort of walk into the code base, say, you know what, there's so much low-hanging fruit in here, there's plenty of peaches, I just need to go in and find them. So you just need to go into a code base and just believe that you can find something. And honestly, more often than not, you probably will. This is me. I've been absolutely surprised. Every single time I've managed to speed something up, I have been shocked at, 1, how easy it was, and 2, the fact that it's like, wait, really? It's like that obvious that we can speed it up in this way? And so what I want everybody to come away from this talk with is hopefully I can inspire you So tomorrow or Monday or whenever you're back, you can sit down, that thing that's been annoying you for ages, that you just sort of take for granted, it's like, oh yeah, now our app just takes a minute to boot up. Well, what are you gonna do? Hopefully I can inspire you to sit down and take an hour to look at it. That's really what this talk is about. So let's start with my first example. I know this isn't a Rails conference, but does this resonate with anybody? Just checking. So this is not Rails specific. It just happens happens to be a good project to demonstrate some of these techniques on. So Rails boot time is slow. I've had this problem so many times. So let's sit down and figure out, we'll hypothesize, well, what does it do? What could possibly be slow? We'll isolate it, figure out which bits are slow, and then figure out how to instrument it and measure. So what does Rails do at startup? Loads bundler and gems, loads up the Rails framework, runs your initializers. I guess it maybe starts a server. But this is kind of basically it, right? This is like 3 seconds of work, right? Be like, well, I guess it does that, I guess it does that, I guess it does that. So okay, well that's a good place to start, right? So let's see if we can isolate those things. This is my favorite way to do an initial test of something. Just time, Ruby, require some stuff, run some code. Turns out in this case that everything is slow, which is good. It's good. It means there's plenty of places to look, right? And this is on a fairly smallish Rails app. Doesn't really do anything. I have a number of different Rails apps. These numbers are not consistent across slides because I switch between apps because they all have something different to show. So this is the first way to isolate. Second way to isolate, this is my favorite thing about Ruby and scripting languages, is you can just throw a thing in the global namespace and go and litter it throughout your code. Right? Obviously, this is not something that you would share with anybody. You wouldn't ship it to production. But doing this sort of thing where you grab a timestamp, write a method to put it out, and then you can just go in and start putting like stamps all through your code. This, I find, is a really great way to just jump into a problem. The other issue I see, like when I'm coming into a problem, it can seem kind of intimidating. Like Rails, I don't really know how it all works. I don't really know what everything's doing. But I can jump in and put statements in code with the best of them, right? Like this is what I call the naive approach. And this is my way of discovering a code base and figuring it out. Now, there are some advanced profilers that will sort of do this automatically for all of your methods, and I'll talk about them later. But that can also be kind of overwhelming, right? You get like this massive trace of like, here is every method execution ever, and you're like, ah! Whereas this, you can just go in and say, okay, well, we're booting, we're loading Rails, we're doing some bundler stuff, et cetera, et cetera, et cetera. What's also cool about this is it helps you figure out where in the code things are happening. So if you don't know about the caller method in Ruby, you need to learn it because this is the other best thing in Ruby. I have a couple of best things in Ruby. And caller combined with the fact, so caller will give you the stack trace of the current spot where you are. Then you can copy this line, open it up in your editor, and it's like some gem somewhere, whatever, change it, rerun your code. This is amazing. You can just go in and change third-party libraries on the fly, which is really, really scary, but really, really useful in development. So here's an example. Initializers. So Rails takes every file in a directory, runs each one of them on boot. And so this was taking a little while. So I thought, oh, well, I could go into every initializer I have and stamp, 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 stamp. But I could just do puts caller, find the for loop that's running over the code. Like, yes, it's in Rails internal, but I can probably recognize a for loop when I see it. And then I can just put some extra stuff in there. And this was really interesting. So I did this on, actually, this is one of the first things that I did 2.5 years ago at Square, where I went and I did this for all of our initializers. And something really stood out at me. And there's one here that you'll notice, it's taking about 4 or 5 seconds for an initializer to run. That's kind of a long time. Seems like too long a time. Right? And as you went in, it turned out that we were shelling out to a bundle exec, so it was reloading the Rails environment again. It was like, well, we can just not do that. And that sped this up quite considerably. I have since either run this or advocated other people do this, literally exactly this. Like open up the Rails code, print stuff out, and like 60% of people find just stuff there that's slow. My favorite was, there was an app that they were using Zookeeper, but they were just using it in production for some coordination stuff. But in development, they were trying to connect to Zookeeper. which wasn't there, so it would time out. Then it would try again, then it would time out, then it would try a third time before it would continue on. So the app was taking ages to start up, and with this, it was sort of kind of obvious what was going on. So if you run a Rails app, you should do this, if you haven't already. You'll find something. Quick aside, I think Rails should do this by default for you and log slow stuff, so I made a pull request. If you think so too, you should check it out. Big part of this, big class of performance problem is not actually a performance problem, but a visibility problem. Somebody said this to me, and I can't remember who it was, and I can't find it on my Twitter, but there's performance problems where you have to go in and change algorithms, and then there's just visibility problems where you're doing something stupid, but you don't know about it. And this is what I consider the class of visibility problem. And there's actually a large class of things that are slow. It's that you don't know what's going on. We have a deployment tool at Square that's written in Ruby, and it was slow when you ran it. And it turned out that it was like doing some Git operations that we could optimize, but that was really obvious once we just put in some logging around, okay, well, what am I doing now? What am I doing now? So whenever you have long pauses of anything, it should be logging, your app should log what it's doing, so you can find this stuff without even having to go looking for it. So that's kind of the obvious stuff, right? So far we haven't talked about anything hard or anything difficult, just put statements and finding stupid things. So you crunch on that a little while, hopefully you'll find something. Then you get down into the kind of trickier situations, and you start having to do the other thing where you need to prove that things are fast. So when you hypothesize that a thing is slow, that's great. Maybe you can prove that it's slow. But if you can't find what's slow, you then need to take the opposite approach and start figuring out, okay, well, what's fast? And how can I prove that this is fast? And so the most obvious one for me when you're loading up an app was, well, let's prove that require is fast. Just requiring files. So you can do this. There's a library probably most people are familiar with called Benchmark in the standard library. It's really simple. You don't even need to use it. It just loops over your code a number of times and tell you how long it took to run. In this case here, I'm creating 10,000 files on the file system and then requiring it in chunks of, like I'm requiring 500, then 1,000, then 1,500, then 2,000, just to see if there's any change between small and large or whatever. And of course, this is going to be really super fast because this is CRuby, and that's awesome. And then I ran it, and I was like, well, so we got 2,500 files. They're not doing anything, and it's taking a bit over a second to load. And that's a long time in computery times. So anyway, the top one is the benchmark output. The bottom one is a Ruby one-liner trying to be a Bash one-liner, except I don't know Bash very well. And Ruby is really good at one-liners. To just make a CSV, which we can then graph. And when I put a graph like this, now it's starting to look pretty scary to me. And this is the thing that I was trying to prove was fast. Turned out, actually, it's looking kind of slow. So, sorry, the colors on this are terrible, but the top line is 1.9, Ruby 1.9 load time. The bottom one is 1.87. And there are two things that are horrifying about this graph. The first one is that kind of exponential-like curve, right? Whenever you see this sort of exponential curve, you should kind of get scared. There are very few computery problems that we deal with day to day that should exhibit this sort of behavior. They should be relatively flat. And the second one that was interesting to me was a large gap between 1.87 and 1.9. So my Rails app at the time was about 2,300 files. So another interesting Ruby thing, you can just monkey patch require if you want to measure stuff. That was kind of neat. So 2,300, which was taking about a second. And I thought this was particularly interesting because 1.87, if you look at it, has the same performance curve, but the absolute number, so the Y scale is over here is about 200 milliseconds for 1.87. So I was like, oh, maybe just nobody's noticed this before. This was in the fairly early days of 1.9, though I was definitely noticing this 1 second load. So the curve was scary, and the difference between 1.87 and 1.9 was pretty scary. Now, when you think about that, it kind of makes sense. The require behavior in 1.9 is much more sensible. It resolves relative paths for you. It's case insensitive. It's really nice. So it is doing extra work. So it is justified in taking some extra time. But this was too much for me. So anyway, now we're at a place that's really, really scary because require is slow, And that's CRuby, and that's C code, and I don't know a thing about C code. I'm a Ruby programmer who just writes Ruby every day. And so this for me is kind of like the take a big breath moment, right? And I have to talk myself up. And so I started with this sort of mantra of believe you're going to find something, right? This is, I wake up and repeat it to myself 5 times every morning. It's that sort of mantra. And I have another one as well, which I use, which is this one. Computers are really stupid. They only do what you tell them. And C code, it's still just code, right? There's function calls. There's variable assignments. I can, if I take a deep breath and just like look in, I'm going to feel a little bit like this guy, but I can probably figure something out. At least that's what I believe before I open up the require code in Ruby and then close my laptop and it's all right, take a deep breath. It's just C code. It's just unfamiliar. I can work with this. And this actually took quite a bit of time for me. It was like calming myself down enough where I could read through this, figure out what was going on. A big part of what I did is say, okay, well, I know it's slow. I don't know exactly why it's slow or where it's slow, but I can just try like commenting out some code branches and see what happens. Seriously. This is a really good strategy. So I actually got to a point where I could require basic files with none of the extra fancy 1.9 stuff and got it down to 1.8.7 performance. I was like, okay, well, now I know, like, this is my naive approach that I started with, right? Just doing stupid stuff. But it's, like, obviously not going to work. But it helps you figure out what's going on. It gets you involved in the code. And, you start seeing patterns. You start, being able to figure out what's going on. And there's some really neat optimizations in here. For instance, like if you require a file in Ruby, it looks for an RB extension. Sometimes it also looks for a .so extension, right? And so naively, you can say, okay, well, give me all the files and then check. Okay, is this an RB one or an SO? No, let's move to the next file, move to the next file. Except whoever requires an SO file, like basically nobody. And so there's some code in here. This is old 1.9, so it's not like this anymore. But there was some code in here to say, well, go through all the Ruby files first and then start looking for SO files, which is, pretty sensible. So this is actually a pretty good read. Part of my approach for this is I really like to rewrite what I'm seeing in something that I'm familiar with. So I went through and I rewrote this in Ruby, or I rewrote the essence of it in Ruby. What does the require algorithm look like in 1.8.7 and 1.9? And I came up with this, which says, okay, well, if we're going to load a file, make sure we haven't loaded it already by iterating through all the existing files, and then loading it and adding it to the end. Now, this doesn't account for all of the exponential thing, but even just from looking at this, you should be able to see, okay, well, I can probably make an algorithmic change here to use a hash or a set rather than an array, and that should speed things up quite considerably, right? And so that was my game plan. It's going to change loaded to be a hash. Now, so I wrote up a proof of concept of this. It was terrible C code. It changed like every line in the file. And the Ruby guys were like, we can't apply that, which is totally justified. I wouldn't have done that either. But I was able to run this on our app just as an RVM patch set and drop our load time from about 17 seconds down to 10 using this patch. So that was pretty cool. Thankfully, the Ruby guys said, well, we're not going to take your patch. We'll write a better one. And they did. And as you can see now, require performance in 2 is much, much faster than it used to be. So that's awesome. And it's also looking much flatter, which is really cool. So anyway, that was my experience with CRuby. The next one I wanted to talk about was this problem. So does this resonate with anybody? Yeah, so my problem here is actually different to what most people experience. Most people, when they're doing integration testing or something like that. My problem was my unit tests are slow. And when I say unit tests, I'm talking about they're not doing any database access, they're not doing any file or network, it's just a file of code that was taking too long. Now this is where, like when I said I really hate slow things, like I really hate slow things. I had unit tests that I thought should have been taking no more than a millisecond that were taking 10 milliseconds, which is unacceptable. So I thought, okay, well, I can look at this, believe I'm going to go in and find a peach. This is RSpec. This was kind of scary at the time. Hadn't really dealt with that before. But applying these 3 steps: hypothesize, isolate, instrument, figure out what's going on. So what does my RSpec test do? Create some doubles, that's fine. Does some verifying things which should be no-opping in unit specs with RSpec fire, which if you're not familiar with, allows you to stub stuff in a fairly safe manner if your things are loaded. So it basically stops you from making stubs that are just totally made up. And we actually just rolled this into RSpec 3, which we released the alpha of yesterday, which is, sorry, the beta of. We changed what we were going to call it because it's actually much more better. It's much better than an alpha. It's definitely a beta. You should try that out. If you wanted help with that, there's a number of RSpec guys around. We can help you out, but it's a really good release. So, and it has all the stuff that I'm about to talk about in it. So if you're really annoyed at your 10 millisecond unit specs, you can get on to RSpec 3. Anyway, and there's some expectation matches. I've actually found performance improvements in all 3 of these, but I'm going to talk about double creation to start with. So the first thing we do is we isolate. We say, okay, well, there's not really that many parameters when you create a double. There's pretty much the number of attributes that you have. And so I created a spec that, once again, you don't need to read it all, but 1,000 times, it'll create a double with 0 attributes, then with 1 attribute, then 2 attributes, then 3, right? And this is the graph, this is what it looks like. 2 things: 1, the curve looks kind of terrible, and 3, we're creating 1,000 doubles with 9 attributes, which in my mind, like, it's not really doing very much. It's taking about 3 seconds. Like, that's a lot of computer time. So I was kind of offended by that. So I thought I'd go in and start poking around. Now, I started with all the approaches that I've already talked about. But then I got to the point, the one that I was talking about is really useful when you have a long thing. You can just log some stuff and figure it out. This is, you know, much smaller time frames, much harder to find, much harder to tease out patterns using that thing. So this is where I switched to using ruby-prof, which is a tool that instruments all of your methods automatically and gives you a really sweet call stack. Now, I want to emphasize this is the first time in the talk that I've mentioned a tool at all. Up until now, it's just been me talking about how I do this. I want everybody to remember that. You don't need tools to speed things up. Sometimes they help, sometimes they're useful, but you really need to approach it without them. And you know, don't let not knowing a tool scare you away from this. So this call stack graph, obviously don't expect you to read all of it, but it gives you the amount of time spent in each of these different methods nested. The interesting ones for me, there's a lot of stuff going on in here, which seems like a lot to me. And more interesting, there's a call down here to kernel.caller, which is that awesome method I showed you earlier that shows the backtrace. We're calling that 5,000 times. Now we've got a double that we're declaring. So this is, 1,000 creations with 5 attributes. So we're creating a double in one spot, and for that double, we're calling caller, which is going to give the same value. We're calling that 5 times. So I look at this, I have no idea how this code works, why it exists, but I'm pretty sure that we should only call that 1,000 times. Right, this is my naive approach. So the very first thing I did was pulled naive up, pulled the caller up, and just called it 1,000 times rather than 5,000. 5x improvement, it was amazing. Well, 5x to that bit. And so then I started thinking, okay, well, why is caller slow? It's just give me a backtrace, right? And so I started poking around. Didn't quite get to the bottom of exactly why it's slow, but it's kind of, because the Ruby VMs like does some fancy stuff, it needs to reconstruct it, or magic. I'm sure there's people in the audience who know much more about that than I do. But one thing I did discover that was interesting is there's a new argument to caller in more recent versions of Ruby where you can say, well, don't give me the entire stack trace, only give me the first 2 lines or the middle 2 lines or something like that. And so I ran some benchmarks on this because why we're doing it in RSpec, which I found out after reading through it, was we're trying to get the first non-RSpec backtrace line to say, hey, this is where the error was in your code. And generally, that's in the top 2 to 7 backtrace lines. So I thought, well, what if rather than pulling the entire backtrace and searching it, we did like a chunking algorithm where we chunked it down. And so I wrote that out. This is kind of what it looks like. It's, you know, about 20% faster. In the common case, it's much faster. So that was a pretty cool find. And so that was an interesting thing I learned about caller. The most interesting thing I learned was that, so you create a double, we're snapshotting the caller so we can use it later. How could you cause a failure? What would ever trigger that caller stack trace? Turns out you can't. We were just using some of the generic RSpec infrastructure to create these doubles that used the caller, but in this particular case, it was never getting used. So we're spending all this time to capture a variable that we never used. So in the end, after optimizing caller, I managed to just get rid of it completely, which initially made me feel kind of stupid. But then I was like, well, this is like, you start with a naive approach, you learn about the code, and then you fix it up. And we use this elsewhere in RSpec anyway, so it still got faster. This is the same thing after I was done. The two things to note are, one, it's a lot simpler. Rather than using all the generic RSpec infrastructure, we added a new concept to make this easier. And it doesn't call out to caller. And that's what the graph looks like. It's pretty flat now. So that's kind of awesome. It's about a 2 or 3x above just using OpenStruct. So it's the same curve, just with a higher constant factor. So we could probably get a little better, but I'm feeling pretty good about that. Anyway, so I just mentioned ruby-prof as one tool. There's some other tools here, perf tools, gtrace, strace. I haven't really used them very much, so I'm not going to speak about them. I'm just throwing some names up if you're interested. Some different things here. Perf tools is a sampling profiler. So ruby-prof, if you run it against code, it slows it down a lot because it instruments it a lot. Perf tools will just look at your code every now and then and be like, what are you doing now? What are you doing now? What are you doing now? Adds very little overhead. So in some cases, you can actually run that in production too. strace, you can track down system calls. If you want to see some cool graphs, search for dtrace and flame graphs. Some people have done some cool stuff for visualizing their things. And this is also exposed in a Ruby 2 API. I think it's trace point, I think. I can't remember, but something like that. Anyway, just a dump of names for you to look into if you're interested. So that's kind of my adventure and the things that I've learned about. Are there any questions about this? I've got a couple of minutes left. Pretty straightforward then? Awesome. I can do that, yeah. I think there's some nice graphs in there. Yep, the back. I did it, and they were like, this is great. Fix up some things. I did. Yeah, and then I actually ended up getting more involved in the project. So it was actually a good way in, and so I'm now a committer on RSpec and helping out there a lot. It was, if you ever want to get like the best, most awesome code review you've had in your life, submit a pull request to RSpec, get Myron to look at it. That man, is he here? Where is he? This man here, he seriously gives like the best code reviews. It's amazing. So I highly recommend. Would submit again. Yes? How long did it take for me to? The require refactoring? Most of my nights for 2 weeks. A lot of that was just like figuring out, like, an hour or two a night for a couple of weeks just to figure out C code mostly. So, yeah, I don't know. If I was actually working full time on it, it would have been a lot quicker. Cool. All right. Well, to just quickly finish up, the things I want you to remember. 1, the computer only does what you tell it. Right? Just remember this. Whenever you're like getting scared or getting intimidated, CRuby is still just C code, right? It might take some time, but you'll be able to figure it out. It's all just function calls in the end. Believe you're going to find something. Just visualize that low-hanging fruit, how tasty that peach is going to be. If you just believe you're going to find something, you probably will. And these 3 things: hypothesize, isolate, and instrument. Thank you very much.